What's going on, everyone? Embedded Monkey here, and today is day 2 of the embedded adventure, um, where I, as a complete beginner in embedded systems, trying to do some cool stuff with ESP32 microcontroller and um, to just learn a bit about the embedded systems. Why am I doing this? You can check the day 0 where I spent like first 10 to 15 minutes to explain why, or you just can like uh, check the description. Yep. So today we are continuing our project with controlling the LED via Wi-Fi, and in the last video I said that there was a lot of theory to cover before we can actually code anything. But to be honest, I've just uploaded a new node right here. Um, where is it? Yep, here it is. Where I researched a bit this topic about the Wi-Fi and how the ESP32 works with Wi-Fi. So I can get you I can give you a little breakdown of things. So the ESP32 have different modes of operation. It can be a station, it can be an access point, it can be a station and an access point at the same time concurrently. There are actually a lot more modes, but these are the most common ones. And on the inner level, how does it work? It has just basically some radio frequency front end that just use some amplifiers and filters for all that stuff to get this radio frequency signal and modulate or demodulate it into the binary one. Okay, and the radio, of course, it has a radio baseband with some receiver and transmitter. I currently didn't dive very deep into this topic to understand actually how they work, but I found, if you're interested, I found this information in the datasheet. Where it is? Yep, in the datasheet. Section 4.6, radio and Wi-Fi, they just list the features of their transmitter, receiver, something about the clock generator, baseband, and so on. Of course, ChatGPT helped a lot to understand these things, but nevertheless. So, today we're going to make some Wi-Fi experiments. I still don't know much about the ESP Wi-Fi API. How does it work? So today's video will be kind of vibe coding. But it probably won't be very interesting because in the last video we assembled the circuit with the traffic lights, and now we have to dive deep into code. But well, embedded is not only about hardware; it's also about software. So, well, okay. So the first thing, okay, I'm just gonna open the project. Let's just do it here in traffic light, I guess, or no. Okay, let it be a separate project. Let's just create another one. Probably gonna call it something like Wi-Fi experiments. Currently, we are moving step by step, like small project by small project, to the controlling LED with Wi-Fi. But I guess we should do some experiments first to actually understand something. Because currently, this the problem with learning embedded is that you can understand these things. Yep, I know how networking works, but how to actually code it on the microcontroller, that's where the interest comes. So yeah. Guess we should include some headers firstly. Yeah, let's start small. We should include something definitely to use these libraries, this beautiful API. Okay, so ESP Wi-Fi we should include. Let's go and do this. And also we should specify it in cmakelist file to actually build it correctly. Let's try it. Okay, so I guess we should write it here. Requires the something wrong with the touchpad. Okay, ESP Wi-Fi. Okay, I will just check that it is built so we don't have problems in future. Well, obviously we will have them, but okay, who cares? Like, the good code doesn't work when you build it first time. Okay, it will build forever, so let's just continue. So the first function that even ChatGPT told me to write, even I didn't ask him, I asked him only about the Wi-Fi stack on the ESP32 microcontroller, is the ESP Wi-Fi in it. So I'm just gonna try to, like, barely understand how this Wi-Fi init config structure is, what fields does it have. So it have some pointer to OC functions, some crypto funcs. Well, I hope I won't need to specify all of those, because firstly I want to just try it out with default settings, and if I needed to specify something for Wi-Fi, for example, some crypto functions, well, okay, then I will set it in this Wi-Fi configuration. So I'm just gonna try to pass the null pointer here. Maybe it'll work. Probably the dumbest thing to do. Firstly, oh my goodness. Okay. The API must be called before all other Wi-Fi API can be called. Always use default macro to initialize the configuration to default values. Okay, so we can probably switch to this default structure and do not specify all of those fields. By the way, it's quite interesting to know what do all of them mean. So probably I'm gonna I hope I will find time to understand all of them, and maybe to load some nodes here. Yep. So let's continue. Where are we? Okay. Yep. So let's just write it. Yes. There's nothing we can do. Yep, and just pass the default macro here, just to play around a bit. Okay. Oh. I just realized that I've edited while building. Yep, that's not a good thing. Wi-Fi init config default. Okay, so where can I get the, by the way, so where can I get the Wi-Fi init config default. I thought it should be here, but okay, maybe it's just built thing. Let's just try to rebuild it. Because I've edited. No, actually not. It's undeclared. Okay. Let's Google it. Okay, maybe, but it does not. It doesn't tell us that the ESP Wi-Fi init function is undefined, so it probably sees this header. Okay, let's just see Wi-Fi init config default. So, okay, thank you, Colbon from Texas, for telling me that this is a function. Okay. Total monkey, bro. Oh, like, of course. The thing is that, damn, how dumb I am. We should pass the pointer here, actually the const pointer here. I wasn't definitely passing the pointer here, so let's try and init config. So we're gonna have the config here, and this thing, well, can I find any definition of, I probably should use something besides the Visual Studio Code, because I'm tired of not seeing like the signature of a function or something else. For the ESP functions, probably should download some other IDE. By the way, you can suggest some IDEs in comments, guys. Because I don't really know anything besides Arduino IDE. Well, I can use Arduino IDE, but probably I won't use Arduino libraries because it's too easy. We don't want easy ways. Oh yeah, and pass, of course, the address here. Okay. Okay, and now it sees this macro. Okay. So there is no problem with it. Probably, yep. The build was perfect. Okay, let's now try to do some other things. Oops. Just VPN turned off. Okay, we also will have to de-init these things to free the resources that Wi-Fi used. Okay, here is the Wi-Fi mode, by the way. I hope that it is what I'm thinking of. Yeah, here we go. So the station mode, the access point mode, the access point mode, the station plus access point mode. Well, seems like these are all modes, so by the way, I was right. These are like 3 main modes, and other ones, as you can see, these are like null, I don't know, some, by the way, Wi-Fi none mode and null mode, are they like equivalent or something else? I don't know. Well, we're just gonna act in station mode, because like this is the most basic ones. Because in the project, in the project, I want to make from ESP, make some kind of server, web server from the ESP32, so we can access it with the IP address, within the local network. Probably I can actually host it, host some, like transmitter somewhere to transmit the HTTP requests, but I guess I will just make it locally first. Wi-Fi set mode, okay. ESP Wi-Fi set mode, and let's set it to the station 1. Okay. So next, I want to, for example, can I just scan the like for Wi-Fi networks around? Like, this is the basic experiment that I would like to do. ESP Wi-Fi start Wi-Fi according to current configuration. If mode is station, create station control blocks and start station. If mode is AP, it creates soft AP control block. By the way, what is soft AP? Okay, it's time for ChatGPT here. Actually, I try to avoid using ChatGPT, but for learning purposes, it's #1 tool. Yep. What is the difference between AP and soft AP? Sorry. The same thing? Okay. So Wi-Fi mode AP means soft AP means software. Oh, okay, software access points. I thought it's like some kind of different access points, some soft. Well, I don't know. Okay, so basically, routers use a dedicated hardware MAC designed specifically for access point operation. Okay. Okay, so in terms of, if we take for example, the router, yeah, it has like the dedicated network card. I guess I said it correctly in English. Network card that actually has its own MAC address, and this and it's fully implemented in hardware. Yep. So even if I remembered right, even some of the many cards are like doing the different MAC level stuff, for example, fragmenting and defragmenting frames and so on and so on. So and in terms of ESP32, of course, it's quite small. Yep. So probably there's no place for a separate chip that will be responsible for the networking here. Well, I think there are actually in notes. I probably didn't cover it. I just wrote the separate on-chip radio system. Well, yeah, it does have a separate radio baseband, because the data sheet told us that it does have a separate receiver and transmitter, but it doesn't mean that it have like separate networking card that supports all of the Mac operations, fragmenting and defragmenting it. Well, at this moment, I hope I understand it right. So okay. By the way, I think we wouldn't have any we won't have any um, hardware parts today, so probably you won't see my table today. Yeah, but I hope we'll get to it maybe next video when I will eventually code the Wi-Fi thing and we'll test it. Probably in a few videos we'll see it. Okay. So I guess I understand it right. So we have the sorry. Shit. Sorry guys, it's cold here. ESP32 implements it in software. Okay, let's assume it to be true. Let's believe the ChatGPT here. But if you guys have like the golden truth for this question, that would be awesome. Like, does ESP32 actually have like separate networking chip, or is just implementing all the logic on the software somehow? I don't really know. Okay, so let's continue. Let's start the ESP Wi-Fi service. By the way, I think it's like the separate task in RTOS, and that's actually another reason why to learn RTOS, which I don't know anything besides like that RTOS doing, except that it's like calculates everything in tasks that can be switched, and it's very time bounded. That's everything I know. Okay, and we should stop it at some moment. So let's just assume that we can stop it. Okay. So this is a stopping point here. Yep, stopping point. All right. So now I want to play around. What can I do here? ESP Wi-Fi connect. Connect Wi-Fi station to the AP. This API link backs. Okay. If station interface is connected to an AP, disconnect. Okay, the scanning triggered by Scan start. Block. Okay, let's see what does this mean. Device channel hidden scan type, scan time. Okay. The found IPs are stored in Wi-Fi driver dynamic allocated memory and then can be freed in get ESP Wi-Fi scan get IP. Okay, so let's just scan for available APs and try to get them, try to get these AP records from the driver memory. So I just firstly need to understand what does this mean, like Wi-Fi scan config, parameters for an SSID. Configuration settings for scanning. If set to null, default settings will be used. Well, let's set it to null. Okay. Just doing basic stuff. The most basic shit. ESP Wi-Fi scan start. Let's do this. Okay. Null. Shit. Null. And what does the block mean here? If block is true, this API will block the caller until the scan is done. Otherwise, it will return immediately. Well, let's just set it to true to get like all the available APs. So let's do the complete scan here, and and let's then call the ESP Wi-Fi scan get AP records. I just want to look for its what does it need. Retrieve the list of APs found during the last scan. The returned AP list is sorted in descending order. Okay. So what do we need to specify? We need to specify the number and the Wi-Fi AP record T. Oh my god. Okay. And what does the scan start return? Oh, okay. It only returns the error here. Yep. So oh yeah, it was said yeah that the found APs are stored in Wi-Fi driver dynamic allocated memory. So it doesn't return anything. Okay. Then let's try to get the AP records. As input param stores mux AP number, AP records can hold as output param, AP param, AP number, this API returns. Okay, so the number param is actually responsible for storing the maximum AP number that AP records can hold. Okay, let's just try to scan for like 3 APs here. Okay, so let's just retrievement. And by the way, look at this. It's uint 16t. So we can store here from 0 to 200 to the 2 to the power of 16 minus 1, which is actually, well, I just want to calculate how much is that here. So we can basically store the okay, let's just do it in the regular calculator. 2 to the power of, I hate Windows calculators. Oh my god. Why is it so strange? Okay. So it's basically just 16 ones. Yep. Oh, just misclicked, yep. Oh yeah, 65,535. That's how much we can store here. I guess it's enough. It's probably enough. Yeah. So AP number, but we'll go with 3. We just need 3 APs here. And Wi-Fi AP record T. Well, array to hold the found APs. So probably this one, yeah, this is actually an array. So we should allocate it firstly. Records can hold as output parameter. It receives the actual AP number. This API returns. Should we allocate it first? Okay, let's assume that we can use the static array here. let's just assume that is true. Record T. So we'll get the AP records. I'm gonna just adjust the microphone. I hope you can hear me well. Okay, so and let's now call the get AP records. And by the way, as far as I understand it, if I understand it right, we can call that only once, because then the memory in Wi-Fi driver will be freed and we won't be able to access them. Okay. Number, and by the way, the address here and here. Okay, AP records. Oh no, we can actually do it like that. Yep. So that's how we can actually get the scanned APs. And I want to somehow output it to the like just to simply print them out. So okay, we can just make this simple printf here. I hope that will be enough. Okay, so sorry guys, programmed in Python a lot, so this should be very tough to program in C again. And C++ is also like, in C++ I would just write like, you know, auto and from the vector, but this is C, so it is what it is. But as far as I know, we can program in Python for ESP32, so probably gonna give it a try. I guess it's a good idea. So print, let's just save it somewhere. Record team. So this is the AP records from I. Okay. So what I want to output here, probably. By the way, what is SSID? Good question. I know what the MAC address is, but what is SSID? Let's actually Google it, I guess. This is a simple question. Refers to the service set identifier of a wireless access point, which is the name of the Wi-Fi network that the AP broadcasts. So actually this is a name. It is the name you see on your device. But it is actually the if it is uint, I'm just interested. Like SSID is uint 8, so it can store values from 0 to 2 to the power of 8, so to 256. That seems like not enough. So it's like Wi-Fi name can hold only 32 symbols? Really? Okay. Well, I didn't know. Okay. So then probably we can convert it to string instead of just pretending that it is not string, like Wi-Fi name, let's say it right, yep, not SSID. Then ap.ssid, but we'll in a very barbarian way we'll convert it to const char pointer. Why not? Then MAC address. Okay, let's just, well, I probably won't output it in a good format, because the MAC address is usually written in form of like I don't know, like 0, 1, 2, 3, 4, 4, and 3 more of those. So like 6 oct integers. Okay, let's just output it somehow. Okay, MAC address. So the MAC address here will be the digit and the ap.bssid. Channel show hidden scan type. Okay, I guess like let's stop with this info. Let's try to build it first. Yeah, finally building something cool. Not only the traffic lights here. Yep. By the way, while it's building, I want to say, okay, it is built. Yeah. So I'm gonna continue in the end of the video. Wi-Fi. Okay, so we have built it. Let's just now flash it to the ESP32. I'm not gonna show you the table today, probably, because, well, we only need the ESP32 itself, and we don't need actually the breadboard here, so no table today. Some isolation here. I don't know, maybe I actually don't need this isolation, but I usually put it on to prevent some accidents. Okay, let's just connect this. Okay, connected. Let's flash it. Port COM5. Let's go. Yep, so we flashed it correctly. Oh, by the way, okay, let's monitor. So we got very strange results. We got failed to deinit Wi-Fi driver. Wait, no. Oh, probably we should have passed to the config to the deinit, actually, before calling it. Well, actually, no. deinit is correct, right here. Alright. So failed to unregister Eric's callbacks. I don't know what it means. Okay. Failed to unregister. CNVPS, NVS open fail. return. Okay, that's strange. That's actually strange here. Wi-Fi failed DNED Wi-Fi driver. Maybe this guy from Texas was right. Let's see him again. Okay, so could not be. What? No. Okay. Let's just Google it. Simply. What's the problem? To the lack of RAM. Wi-Fi driver task. So we got the warning here that we. Okay, let's just check where do we get this error. Let's just make some dumb debug. So here we edited thing, Wi-Fi edited, yay. By the way, I forgot the one important thing, guys. The very important thing here. Extremely important thing. Now we're good. Okay. Wi-Fi needed. Here we set the station mode. Station mode set. Here we started the service. Wi-Fi service started. Yep. Yeah, let's debug all this stuff. Wi-Fi scan started. Okay. And lastly, when we stop this, Wi-Fi service stopped. Service stopped. Okay. And Wi-Fi driver deneeded. Driver deneeded. Okay. So let's build it again and flash it again simultaneously. By the way, guys, while it's flashing, I would like to say thank you to all of you guys who subscribed to me. Yeah, now it's 8 of us, 8 embedded monkeys here. We are now together on this path. That's super cool. So I want to say thank you, and I also want to say that you can take any materials that I leave in the link in the description. Like for example, these beautiful notes in my Google Drive, or these like cool links that I usually just hold here. You can check them out. I'll leave the link in the description. So okay, it has flashed. Let's now monitor. Okay, so hello monkeys. Wi-Fi driver initted. Mode set, service started. So we get all of those errors here. That's actually strange. Maybe we have to de-knit it firstly before knitting. Well, maybe. Let's try to de-knit it first, and then try to init it again. So, firstly, before any any of configuration will try to deinit it. Like first deinit. Yep. Maybe it'll help. Let's try. Yeah, so it's quite monkey method here, but nevertheless, we'll try. Well, it's actually probably useful to see some ESP-IDF examples, but it's not very interesting. It's much more interesting to do it by yourself than to just copy the example and see how it works. It's not very interesting. So we're gonna do some stuff here. Maybe this is one of the most dumbest decisions, but okay. Let's try. Actually, no, we still get this errors failed to deinit Wi-Fi driver. Let's Google this one, because this is an error, you know, like the warnings are not that important in errors, so let's Google it. Wi-Fi driver initialization failed due to lack of, again, due to lack of RAM, but there is no program actually there. Okay, so the monitor is on. I can probably press the reset button here. Again. And again. So it's completely resetted. There should be no actually Wi-Fi driver running here, but it seems like it was running. We tried to init another one, and of course it failed. But seems pretty strange, actually. Okay. Let's read this stuff. Like, let's show I don't have enough internal RAM available. Initializing Wi-Fi. But he actually have the same errors, like failed to register rigs callbacks, failed to deinit, well, let's need some buffers. Be internal, maybe you somehow managed to fill up your internal memory by so much that it cannot allocate that. Confirms that it can work. Let's check the GitHub issue. So here we see the same errors. By the way, followed by the same warning. Problem I tried to eat from tutoring. Okay. Micros and roast too humble. What okay, so set target ESP the menu. Probably should change something in menu config. Okay, by the way, let's check the menu config. Let's check the menu config. Okay. Maybe we should specify something first. Menu config. Okay, so probably not the build type. We probably don't need it here. Yep, I guess we don't really need something in the build menu. Bootloader. Application rulebook. Okay. No. I'm just looking for something related to Wi-Fi. Just anything, basically anything related to Wi-Fi. Log serial flash. Blah 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 blah. Okay. Application manager. No. Serial flasher. that's basically just this is basically the settings of a flasher. Partition table. No. Compiler. Actually, I doubt that there are some compiler optimizations that ruin the Wi-Fi, and probably no, that's some hardware issue. Component. Oh, here we go. Bluetooth. Wireless coexistence. ESP HTTP client. It does have some HTTP support internally. That's quite cool. I guess we probably would need it for the project. But I saw the Wi-Fi here. Let's just check. Max number of Wi-Fi static RX buffers. One moment. RX buffer. Sorry. RX buffer is memory used by the ESP driver firmware to temporarily store by frames before they are processed by higher levels. Essentially, a queue of packets that ESP32 received from the air but hasn't processed yet. Okay. So it's basically a queue for frames, like on the channel. Okay, basically stored in the Wi-Fi. So receives when it demodulates it, validates it. SRC check. Yep. Firmware stores the frame's payload into an RX buffer in ROM. The driver pulls it later and processes it. Okay. Buffer is big for because the CPU cannot process packets instantly, of course. It is used to smooth bursts of incoming traffic. And what error was I getting, by the way? What error? I was getting the failed to unregister RX callbacks, or no. Let's see it here. Actually, I can see it by myself here. With just monitor again, we'll see the error here. So it says hello monkeys, stopped, deleted. By the way, no errors here. Then it calls the Wi-Fi OCNVS open fail, OCNVS open fail, failed to unregister RX callbacks. So probably there is some error with RX buffer. So let's go to menu config again and check it. Come on. Okay, so application manager. No, not here. Not here. Component config Wi-Fi. So we got the RX buffer, max number of Wi-Fi, dynamic RX buffers. Well, okay, the first thing that dynamic and static. There is the max number of static RX buffer and dynamic RX buffers. Which one do I need? actually interesting. Let's just double both if we can. Well, I actually doubt that the ESP32 can't handle, like, need some extra RX buffer adjustment to just scan the Wi-Fi networks. That's strange, actually. Okay, let's set the 20 here. Let's set 64 here. I don't know. Let's just save it. Okay, so we have saved it. We now leave the menu. Just quit. So I just want to know that it was saved, and we just try to flash again. Okay, so one more time, one more thing. Yep, it is perfectly saved. Let's now we can actually flash it right away. Let's flash it. It will rebuild with this new settings. By the way, guys, I want you to know, so let me know in the comments, would you like to get some, I don't know, theoretical videos, like, because I actually enjoy to dive deep into some topics, for example, like writing this stuff, or just exploring some things. Probably it's not that interesting then when I was assembling the circuit. By the way, it's here. I haven't like deassembled it. It's right here. But like, theory is also very important. So if you want, I can probably do some theoretical videos on some topics. I'm actually more of a specialist in software, but hardware also a good thing to learn, and so that's why I actually started embedded. I've told it in the day 0 video and in the description, so yeah, you can, if you want, I can do some theoretical videos where I just learn some theory. And like trying to understand. Well, this video is kind of theoretical because we haven't really touched the ESP32 here. Well, we just flashed the code that we were writing in the whole video just to understand how the Wi-Fi works on the ESP32. So here we go, we are flashing the code. And we'll try to monitor it. Okay, so let's monitor. Same freaking error. Okay, guys, so actually I don't think that I'll be able to fix it today. The hour is coming up. Well, I work actually for 1 hour, so I don't miss the studying, the job, and etc. etc. So only 1 hour in the morning. Unfortunately, I would like to actually do this stuff the whole day, but I have other responsibilities. So I guess I should end this video. Thanks for watching. Oh, here we go. 1 hour have passed. Sorry. So, if you like this video, let me know in the comments. What do you think? Leave a like, subscribe. By the way, subscribe to my Telegram channel if you want. I have a good Telegram channel where I post my different materials with well, something like that, yeah. So if you want, you can subscribe to my Telegram channel. I will leave a link in the description. I guess that's all. So that was Embedded Monkey. Next video tomorrow. Bye everyone.